I'm Anil Kumar sharing with you examples on rate of change will relate distance, speed and time in this particular example and see how to solve similar questions. The question here is two cars leave an intersection at the same time. One car traveling west at 80 kilometers per hour and the other south at 100 kilometers per hour. At what rate are the cars separating half an hour later? So our strategy is first to sketch and understand the scenario. The cars are traveling west and south. So these are the directions. The car traveling west is 80 kilometers per hour, south is 100. So this covers more distance. So we'll just say, let this be the separation between the two cars at any instance of time t. Okay, at any instance of time t, let this be the separation. They are moving at the same time from this intersection. Correct? Now let's read. You have to read your question a couple of times to really get the right equations. Two cars leave an intersection at the same time. One car is traveling west at 80 kilometers per hour. So let's say this is x for us and this is y. So when we are given speed 80 kilometers per hour, we'll write this as dx dt, change in distance, right, which is 80. Forget about units for the time being. And the other going south at 100 kilometers per hour. So we'll say dy dt equals to 100 kilometers per hour, right? Now I'm not putting any negative signs here. My convention here is moving away means distance is increasing and therefore I'm keeping them positive, right? Is that clear to you? So why are these positive? Because they are moving away from a point, the distance is increasing. At what rate are the cars separating half an hour later? So we are interested in time, which is half an hour, right? Okay. No harm in including units. Okay, so we'll just squeeze them in. Right. So let us find the situation after half an hour. What is going to be the distance and what is going to be the separation? Let me call S as the separation. So at t equals to half, since they are moving at the speed of 80 and 100, so we say at t equals to half an hour, what is going to be the x distance? We'll say x distance will be equals to 80 times half, which is 40. Let's write kilometers. And y will be 100 times half, which is equals to 50 kilometers. How about the separation s? The separation s will be square root of 40 square plus 50 square square root, right? There is no harm in calculating these values initially. So we have square root of 40 square plus 50 square. That gives us 40 square root 40. That gives us 10 square root 41. Okay, let's write down 10 square root 41. You could write this answer in decimals also. Converting them to decimals give me 64.03. So let me write down this as 64.03 approximately. Okay. So that is the final condition when we are interested in finding ds dt. So what we are interested in finding, let's highlight that. ds dt, rate of change of separation when t equals to half. Right? This is what we are interested in finding. So I have placed all the things which are known to us and now we need to solve the question. Major issue, right? Now here we have a right triangle, Pythagorean theorem. Always when you have distance, speed, time, you'll find this kind of a situation. So you could say x square plus y square equals to s square equals to s square. Now, once you have this equation, since we have speed in terms of dx dt, we don't have to write an equation. You could have written, let me tell you, x actually speaking will be, since the car is traveling at 80, you could write this as 80t, and y you could write as 100t. Is it okay? Then you have an equation with respect to time. Is it okay? So that could be an alternate way of solving, right? Anyway, we didn't get into this. We'll do implicit derivation. Okay. Now once you have this equation, we'll differentiate with respect to time. So what do we get? We get 2x dx dt plus 2y dy dt equals to 2s ds dt. Do you get that? This could be simplified. We just cancel out these 2's. As you can see, we know what x is, we know what dx dt, y, dy dt, and s. We know all this, and we have to find ds dt. Simple as that. So we don't really have to complicate our equation by introducing t at that stage, especially for those who have learned implicit derivation. Is it okay? So I have many examples where we have incorporated time also. I'll not use that here. Now the question is to rearrange and get ds dt. You could rearrange now or substitute values and then do it. So my suggestion is substitute values and then do it. Is it okay? So let's take up this equation on that side. X times dx dt. What is x equals to? So at the instance when we are really interested in finding all our values, we are looking into this column. Is it okay? So from here we know what x is, what y is, what s is. We also know dx dt, dy dt. Perfect. Let's substitute. X is 40. So we'll write 40 times dx dt is 80. So 40 times, if you want to write in brackets, plus y is 50 times speed, which is 100, equals to s, which we calculated as 64.03, right? 64.03. You could write 10 square root 41. You're using calculator, no problems, right? And then we have times ds dt. So what is ds dt equals to? So clearly ds dt is equal to all this when you multiply. Let me rewrite 40 times 80 plus 50 times 100 divided by, you could write this value 64.03. That's it. And units will be kilometers per hour, correct? So let's calculate. 40 times 80 plus 50 times 100. A word of caution, say equal to here. Since we did not put any brackets, now divide by the denominator, which is 64.03, equal to, so we get some answer 128.06. Let me round it to 1. Okay, we did some approximations. And the units will be kilometers per hour. So that is how it should be done. Perfect. I hope that should not have any difficulty. So my suggestion here is, do not write equation as s will be, you could have written, let me write down the equation for you. Some of you could write like this, which may look simpler for you at this stage. S square equals to 80t whole square plus 100t whole square, right? So for this particular example, that could be a simpler situation to deal with. We are only differentiating with respect to time, and directly we can get our answer, right? But here is a general solution where I'll take up another example. You will understand why this is better. Is it okay? Yes, for this example, it was better to use the particular equation, which I didn't use purposely, right? I hope that really helps. Thanks for watching. Feel free to post comments and share my videos. Thank you and all the best.